top of it. All right, I just emailed y'all a different review that I want to start off with today because I think it's a little bit more indicative of what the test is going to be like, so you may want to check your email and pull that down. I think it was called Review Derivatives number 2 or something, so I'd recommend pulling that down. This is what your test is going to look like tomorrow. You've got 20 multiple guess and 2 free response. The multiple guess are over everything derivative. Okay? So you've got to know power rule, product rule, quotient rule, chain rule, LN, ease, chain rule, inside of chain rule, product rule, chain rule, product rule, logarithmic differentiation, exponential, you name it, you got to be able to do it. Yes, sir? Yes, sir, you can. I am recording this today, so I'll be able to put a video out of this hopefully in a little bit so y'all will know what's going on. I don't know, but they'll be able to hear us. They'll be able to hear us later on if they choose to. So I think it would be wise for us to work through a few of these problems as we go forward here. I think it would benefit you moving into the test. So if you will, download Review Derivatives number 2, something like that, and we will see if we can work through some of these. I gave you your test back. Some of you with your test, the difficulty you had was identifying product rule. That's a common occurrence, it seems like. Anytime 2 things are being multiplied together, product rule must be used. So a couple of you had things like this, where you had x squared y, and you took the derivative of x squared and the derivative of y and didn't use the product rule. That's a no-no. So that's probably the biggest error that I saw with anything there. Does anyone want me to look at anything on their quiz now and try to answer for them? Yes, sir. That is a very good question there. Cosine cubed 4x. That's our function, and we're asked to find the derivative of that. This one is difficult. It's difficult because it's a chain rule twice. I think the key is recognizing what's my inside function to begin with. So in this particular problem, I'm going to rewrite this instead of the cosine cubed 4x like that. The cosine 4x, the whole thing is being cubed. All right? That's another way to recognize that. Now, when I look at it like I've got it written here in the brackets, it's easier to see that the inside function is cosine 4x. So remember, if I'm doing the chain rule here, the chain rule says I bring down the power 3 times the inside function to the second power, so that's just the derivative of the outside thing, times, what's the derivative of the inside thing? Yeah, now you have to be careful. When I'm taking the derivative of the inside thing, it's negative sine 4x. Some of you got there, but that's not all of it either. Times 4, because when I'm taking the derivative of cosine 4x, it's sine of 4x times the derivative of 4x in here, which is another 4. So that's where that was a challenging problem because you had 2 chain rules in there. Common to see that mess up there. Now how can I simplify it? Well, I've got a 3, I've got a negative sign, and I've got a 4. So I'm going to put all of those together, negative 12 cosine squared 4x sine of 4x. And that's what my derivative is. So that's what I would have there. That's a challenging problem because you had the chain rule inside the chain rule. That one is challenging there. As you look at your quiz, as I mentioned just a minute ago, product rule got overlooked by some of you a few times. Anytime you have two things being multiplied, you need to consider the product rule. Anytime you have x's and y's being multiplied, you've got to use the product rule. So just be careful with that, always.
Backwards.
Yes, it's low D high, not high D, low D high minus high D low, not high D low minus low D high. The review, there's one on Moodle, and I just emailed you. The review that we're about to start working on, I just emailed to you. It's review derivatives number 2, I think, or something like that. So that's the problems we're going to work on. Test is 20 multiple guess, 2 FRQs, 1 FRQ on continuity, 1 FRQ on position, velocity, acceleration. The multiple guess is all things derivative. Find the derivative of using everything imaginable, and some things you can't imagine yet. Yes, ma'am?
Sorry, what was the second FRQ?
Position, velocity, acceleration.
What do you mean by
Here's a function, is it continuous at 3? Make this function continuous at 3, something like that. Those are yours to keep and do with as you desire. So, any questions? Any other questions on the quiz? Claire? Okay. Yes, ma'am. We can go over a position, velocity, acceleration problem. If you will take the review number 2 and turn to, where is it? I emailed it to you. Review. Yeah. The review number 2, I just emailed you review number 2, I promise you. Okay, if you've got review number 1 off of, if you've got review number 1, let's start there, okay? Review number 1 off Moodle, we'll start there. And if you'll go to about slide 11, we'll work a position, velocity, acceleration problem. This is a multiple guess. Excuse me, this is not a multiple guess. This is a free response question. Now, my suggestion for getting ready for what's the PVA problem going to look like? It could be something like this. You've got FRQ 12 that we've done. You can look at that. You've got lecture 16 was over PVA problems. You can look at those. You've got FRQ 15 that's due Friday, which I think is a PVA. So any of those problems would be good things to look at. What's the main thing to remember about position, velocity, and acceleration? What's their relationship? Very good. And position, acceleration is second derivative or the first derivative of the velocity. Okay? So all of those things are equal to one another. All right, so this is a relatively simple question then, I think. For the velocity of an object in meters per second is blah. Find the velocity and acceleration when t is 4. So what do you need to do? Plug in 4. V of 4 is 36 minus 16 is 20. Right? It's about slide 11, if I'm not mistaken there. How do I find, what about acceleration now? Take the derivative. So what is the acceleration then, Kelsey? And the acceleration at 4 is -8. All right? I have a question for you. We found that the velocity at 4 was 20. Why isn't the acceleration 0 then? Well, you just said the velocity is 20. What's the derivative of 20? Say again? Yes. Does everybody understand what I'm trying to point you to here? Common mistake students will do. Find the velocity at this point. Well, the velocity is a constant number, so the acceleration must be 0. No. The first thing is to find out what the acceleration is with respect to time. Find out the acceleration with a t in it. Then you plug in the value to find out the actual acceleration. You can't find the velocity at a specific point and then take that number and take the derivative of it to find the acceleration at that particular point. Does that make sense? Always find the acceleration by taking the derivative of the original thing. 7, 8, 9, 10, 11, 12, 13, 14, 15. Everybody showed up. Let's see. Do I have any other PVA problems? I thought I had. Yes. No. Maybe. What other type? Let's make up another position velocity acceleration problem here, okay? You're standing on a cliff that is, let's make it 132 feet high. Okay? The cliff's 132 feet high. You're going to jump up in the air with an initial velocity of 16 feet per second. All right? V sub 0. V naught, V sub 0. Okay? Right, what's the position function? There's our first question. How do I write my function for position? 1/2 g t squared plus what? Anyone remember? You need to. Plus initial position. V sub 0. In my language, it's V sub 0, the initial velocity. S is position. Yeah. Yeah. D for distance, but we don't have distance. We have position, so it's a little different there. But yes, same thing. Yes? Yes, you need to know that. Okay? Now, that's the generic form. Remember, if you know that, you can find the velocity, you can find the acceleration. Now, in this specific case that we're talking about, what is my g? How do I know if it's negative 32 or negative 9.8? Right. Yep. We're in feet. We're in feet here, so you do negative 32. If it were in meters, you do negative 9.8. If it's in kilometers, just cry. Okay? But it should be in feet or meters, one of the two. So feet, we're going to use negative 32. Yes, ma'am? Because we're in feet. We were 132 feet high. We're 16 feet per second. Therefore, the gravity is measured in feet per second squared. All right. If this is 16 meters per second and 132 meters, then we'd use negative 9.8 here. No, it's always 32. Always 32. It's always 32 and always negative 9.8. What good? That's my question. Why is it negative? Gravity is pulling down, pulling me back towards the center of the earth. Now, what am I going to put for the initial velocity here? 16. What am I going to put for the initial position? 132. So there is my position function. And I could clean that up to be negative 16t squared plus 16t plus 132. So what are some other questions I could ask off this? What's the velocity? How do you find it? Derivative. Find the derivative of this. That's negative 32t plus 16. Find the acceleration. Acceleration is derivative of that, which is negative 32. Acceleration is also gravity. We know that, so it has to be negative 32. All right, so those are kind of our functions. Let's ask a question here, okay? When does he reach the highest point? When does a diver, because he's going to jump up in the air and get that, when does he reach his highest point? What is that asking for? When what's positive and then negative. Okay. So this is asking when does the velocity change signs? Okay. Very good. That was my point. That's my next point. For it to change signs, it has to stop. So what does that mean? So when is the velocity equal to 0? Right? So when is the velocity equal to 0? How do we figure that out? Set it equal to 0. Negative 32t plus 16 equals 0. Then go find an Algebra 2 student and find out that t is 1/2. That's probably an Algebra 1 student. I can. Is that high enough? But now what word in the question tells me that's my answer? How do I know I'm looking for when? When tells me time. That's the thing I want you to key in on here. The fact that I said when tells me I'm looking for a time. If I said how high is his maximum point, let's say that. How high is the maximum? What is that asking for?
It's asking for like what's the position. So we would plug it in the original equation for t, we just plug in 0.5.
Yes. How high is asking for position? We want to know the position when? At its maximum. So we want to know how high is saying the position at 1/2 second. So we're going to put 1/2 into the position function. Okay? Y'all comfortable with that? Into the position function. S is our position function. So we're going to plug 1/2 into this equation right here. Negative 16t squared plus 16t plus 32. Let's go down here and do that. Negative 16 times 1/2 squared plus 16 times 1/2 plus 132. Well, 4th of 16 is 4. Negative 4 plus 8 plus 132 is 136. So that's how high his feet get. Okay? That's his maximum height. What if I ask, what is his speed when he reaches the ground? What is his speed when he reaches the ground?
We have to plug in, or we have to know the position.
Very good. Position equals 0. Because remember, we started off at 132 up in the air. So we're going to set the position equal to 0. Negative 16t squared plus 16t plus 132 equals 0. And how are we going to solve that? Factor out a negative 16 if I did this right. T squared minus t plus, I hope 16 goes into 132 nicely. I bet it doesn't. 16 times, been better if it was 144. That'd be 9, yeah, it's going to be 8 point something there. 8 1/4. Okay. T squared minus t plus equals 0. So what would you do now? Oh, it would be minus 8.25. Why would it be minus 8.25, Nick? Took out a negative. Thank you, sir. Yeah, we aren't, but I made up a bad problem. So that's actually not a decimal. That's a fraction. Yes. It's it stops, so it's okay to use. So, but now, how would you do that from here? I'd use a quadratic formula and get some really ugly number. Yes? You wouldn't have to. Yeah, we could take out a positive 16, but then we've got a negative t squared. That makes it ugly if we're trying to factor stuff. And you could just use that and use a quadratic formula if you wanted to. Okay? But any of those we would do, then we're going to get two answers here now. We're going to get two answers, one positive and one negative. So what are we going to do? Yeah. Both of them are real.
The one that was after the problem started.
After the problem started. The problem started at t equals 0. So after the problem started was the positive time. So whichever the positive one gives us our t. Okay, when we factor this out, if we factor or use a quadratic formula, whatever we're going to do, we're going to get t equals a positive number, and we're going to get t equals a negative number. All right? Well, we only need one time. Did he hit the ground twice? Only if he bounced. So we're assuming he didn't bounce, okay? So we need to know, are we concerned about this time over here, the positive one, or the negative one? What did I tell you about the negative, or what did Josh tell us about the negative time? It's before the problem began. Remember the guy was here, he jumped up, and he went down. What's the shape of that? A parabola. So the negative says if he hadn't started off there, if he had been Superman and started back here and just jumped up and jumped down, this would be the negative time back here. This is before the problem started. This is the positive time. Right here. Positive. But this is a time, we get a time out here. Is that our answer? Why not? We're looking for his speed. So how am I going to get a speed out of this? Plug the t into the velocity. Are y'all okay with that? I mean, yes, if I'd made up a better problem, we could finish it off here, but I can't do that stuff in my head there. Now, really tricky question here. Is the speed positive or negative? Thank you. Speed doesn't have a sign. Speed is always positive. So if you put down negative here, it's kind of wrong. All right? You need to put the speed. You have to be careful. If I had said, what is his velocity, negative is okay to write down. But I said, what is his speed? Speed means it's a positive number there, okay? So how fast is he going? I don't want to know what direction. Just want to know how fast.
Always got a positive speed.
Oh, no. Because if he's moving down, oh, no, yes, you're right. He always has a positive speed because, that's right, velocity tells which direction he's going. Speed just says, I know he's moving. He's moving, okay? Velocity says, I know he's moving and I know where he's moving to. Okay? All of those are the type questions that could be dealt into this, okay? It'll be something I would imagine on those like that's what I'd be expecting out of this, okay? So, not as hard as I will get for these here. Let's look at, and we can come back and look at some other FRQs later if we need to, but let's look at some of these problems. This is the review that you got off of Moodle the other day, if you got it. I think that's the first problem on there. Is it? Okay. Now, we've all done something like this on our WebAssign, and it says use logarithmic differentiation. You don't have to. You can. What else could I do instead of logarithmic differentiation here? Product rule, because I've got a multiplication here, and after I do product rule, or when I do product rule, for this second thing, I've got to do chain rule back there, okay? So just be sure that you can do both of those things there. So if I'm going to do this, I would say y prime equals first times the derivative of the second. 45 to the negative 1/2 times 2x plus second, x squared plus 45 to the 1/2 times the derivative of the first, which is just plain old 1. Okay? Now, I can promise you most of you can get to that point. The mistake that you're going to make is you're going to leave out this 2x here if you make a mistake there, okay? I can also promise you that that answer is not on your multiple guess. You have to do some factoring and clean up from there. So the proper thing to do at this point in time is you are going to take out this parentheses here, and how do we decide what power we take out? The lowest, which is a negative 1/2 in this case. X squared plus 45 to the negative 1/2. And when I do that, what am I left with out of this first term here? X squared, because the 1/2 and the 2 factor out, cancel out, So I'm just left with this x and this x. So I get x squared plus 1 times all of this. This is going to be just to the first power. How do I get x squared plus 45 to just be to the first power there? Remember, if I multiply this times this, if I multiply this thing out here times this parentheses, I've got to get back to this thing up here. When I multiply, I add exponents. Negative 1/2 plus 1 gives me a positive 1/2. So in the parentheses, I wind up with just that. Now, with this being to the first power, is the parentheses necessary any longer? Not really. So I can actually simplify what's inside these to 2x squared plus 45. And what can I do with this x squared plus 45 to take it to the bottom and make it into a square root? And that's what you're going to see on your test as the answer there. That's the choice that's there. So you just got to be sure you can recognize that. It's also important for you to be sure and show work where appropriate on this test, okay? Some of you on the one on the test on the quiz yesterday where it was cosine cubed 4x, just circled an answer. I can't give you any partial credit there, okay? So be sure you show me this work, because if you get to here and make a mistake down here, I'll give you partial credit. Even if you get all the way down here and get this answer, Kelsey, and mark the wrong one up there in the A, B, C, and D, I'll give you partial credit on that one. So just be careful with those. Give me something to work with here. I want to help you out. Claire. I've got an x squared here, and I've got an x squared here. It's got a plus sign between x squared plus x squared. Yeah, I'm adding these there. Yes, ma'am. Okay? Clear as mud?
So, real quick, right here on the, like the extra, you have to add the one circle in black with the one circle in black right there.
Yeah.
Those both have to equal 1. They're like the one right above it.
Yes. I think I understand what you're saying. This plus this one has to give me that one there. Those two added together. If you're factoring this out right, this should always be 1. Always. You should always wind up with just that parentheses in place to the first power if you've done it right. Okay, let's don't dwell on any one too very long here. What do you see to do this one here? Product rule. Everybody see product rule? That's your straight product rule. Easy, relatively easy to do. Relatively easy to do at this point in your career here, okay? I'm not going to take time to go through something like this until you tell me you want to here, okay? Some I do want to work through because of the difficulty. Yes, ma'am. Yes, I've got a key with all of them worked out, if I'm not mistaken, and I'm going to email all of that out to you, okay? I'll check that. What do you see here? Product rule, okay? Because I've got a first thing here and a second thing back there. So if we work through this, h prime first square root of x times the derivative of sine, cosine x, plus second sine x times the derivative of the first. What's the derivative of root x? 1/2 x to the negative 1/2. Okay? And it's probably going to be seen, you'll probably see your answer is something like this, x cos x plus sine x over 2 root x. That would probably be the answer that you would see there. Okay? No, just here. We didn't have a 2 root x here. So it's just in the first. I don't think we would combine that down to one fraction there. You could, but I would hope not. What do you see here? Quotient rule, okay? Be sure with quotient rule, low D high minus high D low over the low squared. Sometimes people forget that. Sometimes you forget that, but low D high minus high D low. Do you want me to work through this? Okay. Okay, it's pretty straightforward there. How do you do this now? Quotient or chain, depending on what you want to do. I can do quotient, low, D, high. I could do quotient rule here, or I could do chain rule. Low, D, high, minus high, D, low. I could do that, or I could move this up and make it 9 minus 4x squared to the negative 1. If I do that, then it's negative that thing to the negative 2 times negative 8x, right? Which simplifies out to be 8x over 9 minus 4x squared quantity squared. Either way, you should wind up at that same place there, okay? If I did low D high, I should get there also. Now, what about here? Quotient rule. I would definitely do quotient rule here. Be sure you know your sine, cosine, tan, tan, secant, sines, cosine, all that stuff there. So here, low, D high, 4x cubed, minus high, D low, derivative of cosine is minus sine. A mistake I see you doing here is forgetting to put that minus sign in parentheses, and then when you come back and look at it, you think it's this minus x to the 4th minus sine x. That's not what it is. These two things are being multiplied together, so we should wind up with 4x cubed cosine x plus x to the 4th sine x all over cos squared x. You have to be careful there that you don't mess that up. Easy to make that mistake if you don't put the parentheses there. So we aren't having big difficulties with any of these, are we? Good. I like to, everybody recognize what here? Product rule. You can call this chain rule back here. It's really just the power rule, but either one. But product rule is a big thing you got to be sure you see here. Got to be sure you see the product rule there. Okay. Does this bother you? Right. I've got to do the product rule here and just my my normal sine rule here. So it's going to be first derivative of second plus second derivative of first minus derivative of cosine x. Right? Well, that cleans up to negative x sine x. Wow. That doesn't feel right, does it? Because it started off as two terms and it wound up as one term, but that's correct. And if you were to take the derivative again, it would go back to two terms. So, all right, let's see if we can find anything that bothers you. Second derivative is just doing it twice. Twice as much area to make mistakes, but same thing. Second derivative, that's not complicated. Ooh. Ooh. Yeah, that one's a fun. How do we find the first derivative? Yeah, secant squared. 3 secant squared theta. That's our first derivative. 3 sec squared theta. But how do I take the derivative of sec squared now? Yes, now you've got to do chain rule to get to the next one. Good job, Silas. Double prime. I've got the 3 out here. I've got to use a chain rule on this, which becomes 2 times the secant of theta to the first power times, what's the derivative of secant? Sec tan. Sec theta, tan theta. So that becomes not 32, 6 secant squared theta times the tangent of theta. We okay with that? Good, good, good. Feeling good, feeling good. Yes, my apologies. I'm using the chain rule, so I bring the 2 down, secant to the first, but then I've got to find the derivative of secant, sec tan. that, and then I can do secant times secant is secant squared. And the 3 times the 2 gives me the 6. With me there? So we went from tan to sec squared to sec squared tan. I wonder what would happen if you took the derivative again. Let's don't go there and find out. Let's don't find out right now. Chain rule and quotient on the inside. That's probably the easiest way to do it, is chain rule and then the quotient rule. I could do what? I could do chain rule, product rule, or chain rule, quotient. I can make that x plus 5 squared over x squared plus 3 squared and do all kinds of fun stuff, but I think the easiest thing is chain rule, quotient rule. Yes, ma'am? Yes, you could do that and make it product rule with each one of them being quotient rule. So any of those should work out to be the same. The simplest thing, I believe, is going to be the chain rule, because the chain rule will give us 2 times that thing times low D high minus high high D low all over that thing squared. So I wind up with 2 on the top, x plus 5 on the top, x squared plus 3 minus 2x squared minus 10x all over x squared plus 3 cubed. That's kind of ugly. And then you could clean up that inside even more and make it negative x squared minus 10x minus plus 3, and that'd be as clean as you could get it there. But I think that's the easiest way to do that ugly, ugly stuff there. Just power rule. Yes, we can. All right, so if we're going to look at this, I see product rule first. And as I'm doing product rule, I'm going to have to do chain rule in there, right? So first, I'm going to keep it like it is. Times the derivative of the second, 3s squared, plus the second, s cubed plus 5, times the derivative of the first, 5 halves, that thing to the 3 halves, times 2s. That's what you're going to forget out of that. You're going to forget the chain, that taking the derivative of the inside thing there, if you're going to forget something there. And now, do you see 2 terms? Do you see 1 term here and 1 term here? So what can I factor out of those 2 terms? To the 3 halves power. So I'm going to take out a s squared minus 1 to the 3 halves power. What am I left with up here when I do that? In the s squared minus 1 times 3s squared. Okay? S squared minus 1 times 3s squared. What am I left with back here? Well, I've got this s cubed plus 5. I've got this 5 halves. And I've got this 2s, don't I? Because I took out the s squared minus 1 to the 3 halves. So now I just need to clean up that big old square bracket. So let's do some distributing. And I get 3s to the 4th minus 3s squared. That's distributing here. Over here in the second term, my 2's will cancel. So I've got a 5s on the outside to distribute through there. Is everybody with me on that? So 5s to the 4th plus 25s. And now I just need to clean that up. Oh, yes, this should be 3s to the 4th here. I think I said that and just wrote the wrong thing. Thank y'all for catching that. So now I have like terms with these two. 8s to the 4th minus 3s squared plus 25s times that ugly thing outside to the 3/5. That answer would be there, I'm afraid. That's not pretty, but it'll get there. 3/2, yes, I keep, geez, I'm not good. Geez, I'm not good. I'm too old for this. I need to be doing something else. 3/2. All right. What's that? Is that product rule?
No.
Chain rule for sure. I may think of it as product rule with that 5 times that. Is it necessary to think of it as a product rule? Because derivative of the first is going to be 0. So that's really just chain rule with that particular problem there. That pi is supposed to give you trouble there. All right, yep, it scared you. That's what it's supposed to do. We're going to need to use quotient rule. Low. What's the derivative of sine pi x? Cosine pi x? Times pi. Times pi. Pi is a number. It's not as pretty as 2 and 3, but it's still a number. So don't discriminate against it just because it's not pretty. You still have to take the derivative of pi x. The derivative of pi x is pi. Low d high minus high d low over low squared. Why can't I cancel that x plus 2 in the top and the x plus 2 squared in the bottom and make life easier? This subtraction right here, y'all remember that as you're working tomorrow. This subtraction says, no, I can't cancel out the x plus 2 and the x plus 2 in the bottom. That could get a little bit cleaner, but nothing appreciable. You should be able to recognize that answer as being there in your multiple guess. Now, x's and y's in here. What does that imply to you? dy dx, implicit differentiation. When you look at that, do you see product rule for that middle term? That's what you've got to be sure of.
Teacher, I think two senior boys become by the high school office on their way to speed.
He'll come back in a minute and tell us which two, I guess. 3x dy dx plus 3y plus 3y squared dy dx equals 0. Now, the mistakes I normally see right now are you've forgotten product rule to get this. Several of you got that wrong on the quiz. The other thing that I see is you forget this dy dx right there. One of those two things is what you normally do. But big deal. What do I do now? How am I going to do that, Jamie? Okay. All right, so over here on the other side, I'm going to have minus 2x minus 3y. And what will I have in here? 3x plus 3y squared. So then I will divide, and I get minus 2x minus 3y over 3x plus 3y squared. Now, if all the signs are exactly the opposite, it's exactly the same thing. If that's a plus and that's a plus and that's a minus and that's a minus, it's the same thing because it's just factoring a negative 1 out of both of them. So be sure you can recognize if all your signs wound up being different from what one of the multiple choice is, you still may have the right answer there. All right. Well, we have another period coming to us. We will work some during that period. I'll record once again for those of you that can't be there next period so you can see it. And has anybody got the review number 2 that I emailed to you yet? Okay, I'll be sure that the review number 2 gets out there on Moodle. If it's not, or it is, it's at the bottom on Moodle. It says a test 4 review or something like that. So if you can get that, and that's what we'll do next period, they have some more challenging problems to you.